Hello and welcome. Let's have a talk about this radio. It's a Schaub Lorenz Amigo T20L. It's a German portable radio, fully transistorized and produced between 1961 and 1963. I found it on a flea market last year, well, before the coronavirus hit us. And I did buy it because it was still in a reasonable condition. Most of these units now are in a terrible state. It was not working anymore, which I did expect it, of course, and this is why it was not working. This is a picture of the interior. So it was not so good, but I'll explain that to you a little bit in a few minutes. Anyway, the unit is working now, so this is the volume control. This is the on-off button. As you can hear, it starts to work. This is tone, long wave, medium wave, only hum because of all the electronic equipment here, and this is FM. It will play better when I take out the antenna.
Die kat je planten kapot. Nou, accepteer je. En dan vindt de kat het niet fijn als je op een stoel zit. Nou, dat accepteer je.
Despite the age, the unit is still quite sensitive after the repair. And the sound is quite okay. So, top view, there is only the handle. Well, the rubber is completely cracked because of the age. Still looking for another rubber, but I guess all rubbers of this age will be in about the same condition, so that's hopeless. Back side, bottom side, so here is the battery cover, and there are two holes for marked service. This is just to be able to take off the back side. One side nothing, and the other side there is a hole for an external antenna if you want to use it with external antenna, but it has a ferrite antenna included, so normally you don't need that so much. The schematic diagram of this radio is really very typical. Maybe it was not so typical at that time because it's one of the first one with transistors. So there is one RF amplifier for the FM, and then this is the oscillator mixer stage. So these are very early RF transistors. This is the AM stage, medium wave, long wave tuning circuit. Then for FM, first EF stage, second and third EF stage. For AM, this is also the local oscillator. Because those transistors are so old, maybe they are mesas, I didn't check for this type, maybe they are mesas or surface barriers, they need neutralization to avoid oscillation because of the big capacitance between base and collector. So they send opposite phase signal. You see, this is the connection point of the transformer, so it's opposite phase. They send back with a very small capacitor, 3 picofarad, to compensate for this capacitor. This one has an adjustable one, and also the 30F transistor has this small capacitor. Then there is a typical ratio detector, which is not symmetrically grounded, so we cannot use AFC, but this radio doesn't have EFC, no problem. And the AM detector. Then we go to the volume control and the tone switch. Then there is a preamp. This is the driver stage and the final output push-pull. As you can see, the driver stage drives the final transistors with a transformer, which was very normal at that time. Transformers were not so expensive as an extra transistor, by the way. And also at the output we have a transformer. Supply is done by 4 monocells, D cells, so 6 volt. And this radio has something quite unique. It has a stabilizing element S1200, so stabilizer 1200, it's German Stabilisierung 1200, which means this element stabilizes at 1.2 volt. Why is it needed for? Well, for the polarization of all transistors, even for the quiescent current or the bias current for the final stages, they will use this stabilized voltage. You see it return to all bias circuits, even in the tuner section. And the benefit of this is when these batteries go down, the bias of the all transistors remains good, so the transistors will be longer in their correct range, which is most class A and this is class B. So the radio can perform longer even when the battery voltage is going seriously down. That is a very nice idea, but this stabilization element, it's not a Zener diode. Actually, it's a very early, I have it here, nickel cadmium or DIAC cell. So because this is nickel cadmium cell, when you're loading it, it will limit the voltage to 1.2 volt. But there is also a danger, because these elements, with the time, they will start to leak or to sweat and eat all the surrounding electronics or copper or wiring around them. So this is a little danger for this radio, and it's also the main reason why this unit was not working anymore. Let's see the inside. I just need to open, even not fully, just unscrew the two service screws, and basically I can take off the cover. So here is the section where the battery was mounted. That's a picture from the other side. Because this battery has been so leaky, and maybe together with leaking batteries, all components around it are attacked. One of them is the bias potentiometer for the final stages. As you can see, nothing is remaining of those components. I have here the original potentiometer, parts of the carbon track are just gone. So this is the last EF transformer for the FM and also the radio detector transformer. Another picture where you can see, so if you have a radio like this, you need to remove this kind of battery as quick as possible, and it's very simple. You replace it by 1.2 Zener diode or 2 silicium diodes in series. By the way, this can hide the AM and FM detector diodes. Here I opened the can. You can see how much the copper below it is fully attacked by the DIAC cell and maybe by a leaking battery. So this is the radio detector ALCO. Also this one didn't look very good, so I took out the two flat packs, the two little PCBs, to clean up the whole mess here. Also you can see I already installed the two silicium diodes to replace the DIAC cell. These are the two little flat packs. Well, they are very early flat packs. I guess that name was not used at that time, but anyway, let's call them flat packs. So this is the AM detector diode, and this is the radio detector diodes and the radio detector ALCO. As you can see, the cap came off and it was almost completely dried out, so this one was replaced. Then after cleanup it looked like this. I also checked this capacitor because it is under the can, under the cover, and it was a little bit leaky, so I also replaced this one. I guess this is a kind of paper capacitor. It's not a polyester type or a plastic foil. It's still the old type, even if it looks like it is a polyester. It's not. So then I remounted the flat packs and the tin can and took over the last sections of the AM EF section, and this is the FM ratio detector and last EF stage, to look underneath. And yes, also there it was fully corroded, and even the little cardboards, black cardboards that are together with the transformer to insulate them from the copper, they were fully soaked by this acid and base from the battery. By the way, this is the new trimmer I installed for the bias of the final stage. And then after this is a closer look to the positions of the F transformers, and then I cleaned it up fully and even cleaned the cardboards before installation. So now the transformers are back, not cannot yet, because I wanted to show you the beautiful interior of this kind of 1961 technology. So the ferrite cores with coal holders inside, and these are the first type of plastic foil wound capacitors. Even they are cracked, they are still okay. So yes, so this whole section, here are the two EF transformers, and here are the flat packs. This, and here was the battery, and this hole is for the bias current. Anyway, so this was the removed section and cleaned up. So after that the radio started to play, and when it was open I also decided, so this was the little leaky paper capacitor. I found one resistor who was losing his cap, and I replaced the 1 microfarad coupling capacitors in the audio circuit, because I found they were a little bit gone. There was audio coming through, but there was almost no bass in the speaker sound. So afterwards it did go back, and yes, it leads to this quite nice result. So well, thank you for watching this video, and if you have one of these sharp lorenz, please check the interior and remove this very old DXL. Thank you for watching. Bye bye.